Good day. Hope all is well. What I'd like to do today is address the question of why do stars twinkle and why don't planets seem to twinkle. Before I get into that, once again, thank you for your comments, your support. I'm constantly trying new things here, although it may not seem like that to you. And I'm finding out I'm getting much too wordy, and maybe the audio quality isn't all that good, so I need to work on some of that to help make this a better experience for you. Some of you mentioned, gee, this may be a good practice overall for general faculty. Why not suggest this as a best practice? And I think it is a good idea. I wouldn't be surprised to see if a medium like this is used extensively in the future. There are always, however, ramifications to anything. Maybe way beyond call of duty to ask some faculty to make videos like this. It may also have other ramifications. Certainly it's easy for me to sit here and talk about astronomy given my passion for it, and because it's actually quite an easy subject to talk about. Has a lot of visual benefits to using a video. I'm not sure that accounting would quite have the same benefit from this. So thanks again, and let's move on with the main question. Why do stars twinkle? Of course you can go to Google, Wikipedia, type in why do stars twinkle, and you'll get a reasonable answer. My purpose here is to really describe what's going on to you in a rather concise manner, and I'm trying to keep it within a few minutes. What we basically have are a couple of important ingredients that create this, what effectively is the effect of twinkling. We have the Earth, and we're all sitting here on the surface of the Earth, and we look at the sky basically through a layer of gas. That gas is called the atmosphere. That gas is about 10 to 15 kilometers thick. It's thick enough you can breathe it. And we're actually quite fortunate on our planet that we can see through our atmosphere. If we were on Venus, we wouldn't be able to do so. Yet, there is a distortion created by gas. Any type of medium that transmits light actually makes light travel slower. It can actually make light bend in strange ways. A quick example, this is an exaggeration, but here's a glass of water. And imagine that water being gas, and as you see, the effect of that, it distorts the light coming from my face to the camera. No longer do you see my image, you see something highly distorted. Of course, this is a great exaggeration. Using the same idea, let's imagine a piece of light that is traveling. Now this is before the glass. If I go after the glass, you see there's a distortion. So the image again of the light passing is distorted. We've established that. So now let's get to the next concept, stars. Stars are very far away from us. To appreciate that, look at how long it takes light to get from the sun to the Earth. It takes about 8.3 minutes. The nearest star, it takes 4.2 years for the light from Alpha Centauri to reach Earth. 4.2 years versus 8.2 minutes. Let's talk about that then. Here's our friend the orange again. Okay? And what I'm going to do is I'm going to go and bring Mr. Orange back. Now notice what's happening as I bring Mr. Orange back. This is my finger still keeping the same frame of reference. So it keeps getting smaller and smaller. In other words, as things go backwards, they get smaller and smaller. They're further away from you. Eventually, it's just going to become a little dot. So what you would see is this orange would become an orange dot to you. Well, stars are very, very big. They're as big as the sun. Some are even much bigger. Yet they look like little tiny dots. And that's because they're effectively so far away we treat them as dots. What that means is that the light coming from that star far, far away, let's see if I can get back here. Here we are. Is all kind of coming in one clear path to us. Okay, here's a star, and it's a nice one clear path. Okay, That means that all that light follows the exact same path to the atmosphere. All that light is disturbed in exactly the same way. If it's disturbed in exactly the same way, we see a twinkle. A little bit light, and it's jiggling and it's twinkling. Planet is close to Earth. Maybe, for example, Mars might be 50 million miles right now. It's no longer a dot, but it's something of much larger size. Therefore, the light leaving it is leaving it from many different points on the surface. It actually takes across the sky at subtends an angle. That means that that light passing through the atmosphere is actually taking a slightly different optical path. It's coming from different points on the surface of the planet. Turns out that that path, those different paths are a little bit different from each other, and they are affected a little bit differently. The net effect is that even though each little light ray wiggles a little bit, all the light rays summed up over this don't wiggle. You get kind of like a constant glow. That's basically the explanation. The atmosphere distorts. It makes light bend. It actually makes light travel slower. Stars are treated as light point sources. They're infinitely tiny dots, therefore all the light is exactly on the same optical path, whereas a planet is of finite size. It's a rather large object in the sky. Now what's deceiving is when you look at stars and you look at planets, you say, well, they're about the same size, but the answer is no, they're not. And really the reason why the stars look big is because of that twinkling effect. Okay, so there we have it. Hope this was useful. Next video, I want to talk about the structure of the universe. You notice each week we're starting from small to big. We started with our celestial neighborhood, the moon, earth, sun. Now we're going out next week to talk about the solar system. That's another scale. Now we're talking about a couple of billion miles rather than 100 million miles. Next scale, we're going to talk about the stars, and they're bigger and they tend to be on the order of light years away. And then we're going to talk about galaxies, which can be anywhere from hundreds of thousands of light years to billions of light years away. The universe is huge. What I want to talk about are the elements of the universe. So we're going to start not only from our little perspective of us on Earth, where we talk about things like meters and so as a scale length, but we'll start at the subatomic scale and work our way up to the grand scale of the total size of the universe. It should be interesting, and it's important. This will give you a good perspective. Hope you got some good images here. Remember, water, gas distorts, light, point source, far away, nearby planets are not far away, comparatively speaking. That's it for today. If you have any questions, please contact me. Hope all is well. Have a good day.